Hello, I am Indrajyoti Gaine. I am a PhD scholar at Department of Mathematics and Statistics, IIT Kanpur, and presently I am a PMRF fellow. And before that, I was getting CSR fellowship. I also have cleared CSR net with 108 rank. Okay, so in the last class we have discussed about some angles, and so we have discussed about first angle, second how to measure an angle. So we have discussed about two type of measurement. One is degree measure and another is radian measure. Okay. So degree measure was nothing but we just divided the complete revolution of a vector or of a ray and divided it into equally 360 parts, and each part was called as degree measure. Okay, and radian measure was nothing but the arc length, depending on the arc length of a unit circle, and depending on the length of the arc length we can measure the radian. Okay, so usually we call one radian equals to the one arc length. So unit arc length makes the angle which is called one radian. Okay, so today we will discuss about first we will discuss relation between radian and real numbers, and second we will discuss relation between radian and degree measure. Okay, so first discuss this thing. So let us assume that this is our initial vector, this is our initial ray, and the red one was denoted by the terminal part. So this is the terminal ray, this is the origin O, or you can write it as a white point, vertex O. This is our OA, and this is our OA prime. Okay, now the thing is, we have discussed that if we draw a circle of radius 1 around this vertex O, so this length will be 1 and this length will be 1. Now whatever is the arc length will be, we will say this angle theta equals to x radian. If x equals to 1, then that angle is called 1 radian, and other than 1, whatever will be, that will be x radian. Now just zoom in this section. Let us zoom in this portion. So suppose here is the unit circle. Okay, and this is the origin O or vertex. This is the initial ray, call it as OA. Now let us draw a tangent at the on this circle along the line and along the point A. Okay, you can see the tangent along this point. So this will be and let us denote the positive axis along this 1 and negative as -1. So this is 1, this is 2, this is 3, this is -1, this is -2, this is -3. Now if I wrap this positive axis, say this is our blue line is the positive axis of real line, and this is the negative axis of real line. Now if you wrap this blue line or red line along this unit circle, you can see that one length, that is this length is nothing but unit arc length along this circle. Okay, so this will give us 1 radian. Similarly for 2, if I say this 2 is like blue, this length will give the twice arc length along this circle. So this will give us radian 2. This will give us radian 2. So by this, similarly, if you draw the negative lines, so if we draw this one, so this will give us unit arc length along this circle. So this will give minus 1 radian. So by this, we can say the radian measure and real number can be considered as one and the same. So note, this thing give us the note that the radian measure and real numbers can be considered as one and same. Okay, so this is our note. Okay, so now this is the one-to-one correspondence between radian measure and real numbers. Now we will discuss the relation between degree measure and radian measure. Relation between the degree measure and the radian measure. Okay, so in the last class we have discussed one thing, that a complete revolution, this is equals to 360 degree. This is equals to 360 degree, and obviously this is equals to 2 pi radian. Okay, so this thing gives us the relation that 360 degree equals to 2 pi radian. So from here we can say that 180 degree equals to pi radian. This thing implies two things. 1 degree equals to pi by 180 radian, or 1 radian equals to 180 degree by pi, or you can say 180 by pi degree, 180 by pi degree. Okay, so this is the relation between degree measure and radian measure. Clear? Now, using this relation between two measure and one-to-one correspondence between length and radian measure, and also in the last class we have discussed about a formula like this formula. Which one we have discussed? This formula. Marking in the red color, L equals to mr, where L was the arc length, R was the radius, and m was the measure of the radian in radian. So depending on that formula and relationship between this degree and radian, we can solve many problems. So let us discuss the problems. Before that, let us be aware of some significant angles, that is significant degree and radian relation. So usually I've seen some relation between pi and, like, usually we do 30 degree equals to pi by 6 or 90 degree equals to pi by 2. So from where these relations are coming? So here is the relations these are coming. So let us see those part. So we have all know about 180 degree equals to pi radian. So usually we need, or in general we are aware of few important degrees or few important angles. Those are of 30 degree, 60 degree, 90 degree, 45 degree, and 270 degree, 60 degree, and these all are very much important angles we are aware of. So this thing we know from here. What about 60 degree? That also we know, 2 pi radian. Now what about 30 degree? 30 degree is nothing but 180 degree by 6, which is nothing but pi by 6 radian. Similarly for 60 degree we know 180 degree divided by 3, that is pi radian by 3. So thus we can find the correspondence between these important degree measures and their radians. Okay. So now let us discuss few examples. So example 1. So first example we can discuss is to convert a degree measure into radian measure. So the question is 40 degree 20 minute. This degree measure equals to how much in radian? So how can we find this thing? So we will use this formula. We will use this relationship. Okay, this relationship. So how can I do that? So first of all, 40 degree 20 minute. This implies 40 into 1 by 3 degree. That is 121 into 3 degree. Now we all know about this relation, 180 degree equals to pi radian. Then 1 degree equals to pi by 180 radian. Then what about 121 divided by 3 degree? This is nothing but 180 into 121 into 3, this much radian, this much radian. So this thing gives us 121 pi, this much radian. Okay, so 40 degree 20 minute equals to this radian. Fine, this not much clear. So this much radian. Okay. So by similar way, if someone give the measure in radian, then using this formula only, one can find how much measure will be in degree, and that can be converted in minute depending on this quotients, depending on like 1 by, here it was 1 by 3. So why it is 1 by 3? Because usually 1 degree equals to 60 minutes. So depending by that, 20 degree 20 is minute means 1 by 3 degree. So thus one can convert from degree and minute to degree only or minute only. So usually we are aware of this relation between degree measure and radian measure. That's why we usually convert the measure in minutes into the measure of degree with using the fractions and all this, so that the work can be easy. Okay. So next example is So the next example was little bit discussed. No. Okay. Question is, find the radius of the circle in which a central angle of 60-degree intercepts an arc of length and arc of length 37.4 centimeter. Okay, so here you can use this thing, 22 by 7. Usually pi is equivalent to 22 by 7. So let us understand the question. So what is the question is here? Find the radius of the circle in which a center angle of 60-degree intercept an arc of length 37.4 centimeter. So let us draw the diagram first. So what they have asked, if this is our starting point, okay, and it is saying that that made a 60-degree angle. So suppose this is your 60-degree angle. So this is our 60-degree angle. Then as it is given in positive direction, positive 60-degree, that's why we have drawn it is anti-clockwise. In the rotation will be in anti-clockwise direction. Depending on the sign of the degree or angle, one can take positive or clockwise or anti-clockwise direction. Okay, so here it is the initial is like by blue, and the terminal should be in red. Okay, so this is your convenient way to understand these things. And here it is our origin. Now the question is, we need to find the radius of that circle which makes the arc length of this distance. So suppose this is the circle is this. This is our circle. This is our circle. Okay. So what is the radius? This should be radius. And similarly, this should be radius. And this is our arc length. And this is given by 37.4 centimeter. Now what we need to find? We need to find this R. Now, if I know this angle in term of theta, in term of radian, if we know about this angle theta in term of radian, then we can clearly say that x equals to r theta, right? X equals to r theta, which will imply us r, which is the radius of the circle, should be equals to x by theta, where x equals to 37 by 4 centimeter and theta should be radian, the measure of the angle with respect to radian. So what we need right now? We have the angle with respect to degree measure, but we need in term of radian measure. So just transfer this degree measure into radian measure. So already we have done this part here. So 60 degree equals to pi by 3 radian, right? So we know that we already have discussed. We know that 60 degree equals to pi by 3 radian. So just we need to put these values here. So what will be this r? R will be x by theta. Now what is our x? What is our x? 37 by 4, and theta is pi by 3. So this will give us 37.4 into 3 divided by pi. Now this will give us 37.4 into 3 into 7 divided by 22. Now if I calculate this part, you will get 35.7 centimeter. So what will be the radius of this circle? This will be 35.7 centimeter. So using this concept, you can find the radius of the circle, which makes an arc length x with the angle 60. Okay. Now let us discuss the next example, which is nothing but we need to find the length L or length x. We need to find this x where they have given this r. Okay. So it is little twisted. The question is little twisted. Whatever we have done in the last class, that question is itself, but it is in little twisted form. So the question is the minute hand of a watch which has length with 1.5 centimeter and watch with length moves in 40 minutes. How far? Okay, not like that. Watch has length. So how far its tip in the top of the minute hand move in 40 minutes. Okay, so the question is given in some little twisted manner. So let us understand how much is 40 minutes. So a complete revolution of a minute hand of an watch means 60 minutes of revolution. Okay. Now this minute is not in degree and minute. Just recall that not is not in the case of degree and 60 parts of 1 degree is a minute. Not like that. This minute is the time limit. It is a measure of time. This is not a measure of angle. Okay. So so don't get confused if they given in this given 40 minutes. So usually whenever we write minute angle, I mean when we represent an angle with respect to minute, then we usually write like this, like 40 minute. That's why the notational difference is there. It is given the time. Now usually a minute hand rotates the full revolution with 60 minutes, right? So in 40 minutes, how much revolution it should complete? So 2/3 of the complete revolution. So in 40 minutes, minute hand will complete 2/3 of a complete revolution. Okay. Now one revolution equals to 2 pi radian. Then what about 2/3 of one revolution? That is nothing but 4 pi by 3 radian. So now the question becomes, how far does the tip move when the angle with the initial and terminal will be 4 pi by 3. Now in this case the minute hand is moving in the direction of clockwise. So usually you should write this as minus 4 pi by 3 radian. So usually we draw like this. If this is our starting point was this, because minute hand starts from here, and it is presently at this point here, right? So if I draw the circle completely, this is our watch, suppose. Okay, so this completes this revolution, and the angle will be minus 4 pi by 3. So this is our starting point, and this is our ending point. Okay, ending point starts A dash, starting is A, this is O. Okay, so what we need to find, we are aware of this length, we are aware of this length. So what is this? It's the distance of this minute hand, which is nothing but 1.5 centimeter. Similarly here it is 1.5 centimeter. Now we need to know what is the value of this x, or you can say L, whatever you are convenient with. We need to find this x. So how we can find? So x equals to 4 pi by 3 into the length of this hand, this much centimeter. Now one can ask that why I have written minus pi by 3 here, but here I am putting only 4 pi by 3. So in this case we are putting the measurement. I am not worried about rotational direction. So whichever direction it rotates, the measurement will be same until when the measurement will be same, the length will come same. The length of the x or length of this r does not depend on the direction of rotation. Okay, so that's why we have written this thing like this. Okay, so 4 pi by 3 into 1.5 centimeter, which gives us 6.28 centimeter, where use the fact that pi equals to 22 by 7. Okay, by this you can find the length of the how far the tip of the minute watch has moved in these 40 minutes, or you can say with this, make this angle with the initial position. Now let us discuss a beautiful example. If the arcs of the same length in two circles subtend angle 65 degree and 110 degree center, then find the ratio of their radii. Okay, so what is the question? If the arcs of the same length in two circles subtend angle 65 and 110 at the center, then find the ratio of their radii. Okay, radii means the radius of the circle. So suppose let us draw two circles in different color. So this is one circle and this is another circle. So by watching the drawing, you can clearly say that these two circles don't have same radius. These two circles don't have same radius. What is the radius of this thing? Which is this, and in this case, this will be this. Okay. Now the question is, the arc length is same. So in both cases, suppose this is arc length of x here. So obviously the arc length or distance covered will be much here. Okay. Okay. So if if the arc length of both the circles are same, then the angle made by the arc length in the center or vertex will be different for two circles depending on their radius. Because we know the radian and 112 corresponding between radian and real number. So whenever the circle has small radius, then it has small perimeter. So if it has small perimeter, then the distance covered, if someone walks 5 steps, or you can say if someone walks 10 steps, then distance covered in the small circle will be greater, or distance covered in a large circle will be smaller. Okay, so that's why the figures will be like this. Now, according to the question, this angle is 65 degree and this angle will be 110 degree. Okay, so at first we need to convert these two angle measures into radian. Okay, so for that, what will be 65 degree means 65 degree, this is equals to pi by 182 into 65, this much radian, and 110 degree equals to pi by 180 into 110, this much radian. Okay, now we have same arc length. So according to the question, if the red one has radius r1 and blue one has radii r2, which has moved a little bit, okay, right now r2, then we can write r1 into this pi into 110 by 180, this equals to x, and similarly r2 into pi into 65 divided by 180 is equals to x. Now if I compare these two values, then from here and here I can write that r1 into pi into 110 divided by 180, this is equals to r2 into pi into 65 divided by 180. Okay, now what will they are giving? r1 by r2, this is nothing but 65 divided by 110. Okay, I'm correcting. So if I divided it by 5, both sides up and down, it will give 13 by 22. So the ratio will be r1 is to r2 equals to 13 is to 22. This is our ratio of the radii of two circles. Okay, so thus we can find the ratio. Okay, so let us discuss a question so that a wheel makes 360 numbers of revolution in 1 minute. 1 minute means measure in time measure. Okay, so the question is, how many radians does it turn? How many radians does it turn in just 1 second? This is the question. So clearly see that in 1 minute there are 60 seconds. Okay, so in 60 seconds the complete revolution is 360. So in 1 second the number of revolution will be 60. Now in one revolution the radian measure is 2 pi, because the complete revolution is done, so the measure will be 2 pi. So 60 revolution means 2 pi into 60 radian. So how many radian does it turn? The number will be 2 pi into 60. That is 120 pi. 120 pi. Okay. So thus we can solve the problems. Okay. Let us discuss some new function, trigonometric functions. Trigonometric functions. Wrong here. Trigonometric functions. Okay. So till now we have seen some examples like if this is our triangle, right angle triangle. What is right angle triangle? Because of this angle, this is our 90-degree angle, this is our theta, and if this is O A B, then one know about this thing that cos theta equals to OA divided by OB, and sin theta equals to OB divided by AB. Okay, so we know about these two things, and from Pythagoras law we know sin square theta plus cos theta equals to 1. Now in this section we will generalize this part. So this is our x-axis and y-axis. This is our x-axis and y-axis. X-axis and y-axis. And this is our unit circle drawn with center radius, with origin at the center, with radius 1. Okay. Okay. Now this is the position of any point P. Okay. So how we can achieve this point P? So the location of this point should be distance covered. Let us first go in this direction. First go from origin. How can I go P? So one way is this. And what about the another way? Another way will be from here to here. Then go from here to here. So here you can see an angle of 90 degree. Okay. So it is a right angle triangle. Now suppose we all know that this length is 1. These two lengths are 1. 1. Okay. So if this distance is covered is x, this arc length is x, then what will be the measure of this angle? This angle will be x radian. X radian. Now if this distance is a and this distance is b, then the location of this point will be a comma b. A comma b. Now from using this formula, above formula, we can clearly say that cos x equals to a and sin x equals to b. And from here, Pythagoras law, if I apply that, a square plus b square should be equals to 1 square, which is nothing but 1, which is giving us the formula like sin square x plus cos square x equals to 1. Okay? This thing is clear. Now, let us discuss two angles. So, let us discuss this thing in different picture. Okay. Now, x can be anything. X is radian. So before that we had discussed like theta will be any angle. Now x is measured in radian. Now x can be any real number, right? X can be any real number. Now what is the value of the sin x and cos x? The question is this. We can this is a function. Cos and sin are two functions which are called as trigonometric function. Now this can assume or this can take any real number as its domain. So domain can be any real number because x is a radian measure and x can be any real number. Because we have on the beginning of this class we have discussed the one-to-one correspondence between radian and real number. Okay, so the question is, what will be the value of cos x and sin x, and what will be its domain, and what are the specific values? What should be the specific values? Okay, so let us draw this with some new picture. Okay, let us draw it in small pictures. Okay, this is our unit circle. Now, if this x equals to 0, if this x equals to 0, x equals to 0 means the point will be at the point here, because usually we start from this line and we end on this line. Okay, so usually we start from this OA, or you can say this real axis, positive real axis, positive real axis. Okay, we start from positive real axis. So starting point and ending point are same. So here you can clearly see that a equals to 0 and a equals to 1, a equals to 1 and b equals to 0. So if x equals to 0, then a equals to 1 and b equals to 0. So this thing will imply as cos 0. That is the real number 0. That is not in so cos 0 equals to cos 0 equals to 1 and sin 0 equals to 0. Now, surprisingly, the 0 radian and 0 degree are same. So that's why one can again say that cos 0 degree equals to 1, sin 0 degree equals to 0. From this, just compare these two figures. So here it has a positive value, that's why we got from positive value of a and b. But in this case, whenever x equals to 0, then our b is 0, because the p is lying on the real positive real axis. So in that case, we have a equals to 1, but b should be equals to 0. Okay, so thus we can find the angle of cos 0 sin 0. Now what if x equals to pi by 2, or you can say 90 degree? If x equals to 0, equals to 90 degree, or you can say pi by 2. Pi by 2 in term of radian. Okay, usually pi by 2 denotes for 90 degree. Okay, in that case, let us draw the figure again here. So this is the unit circle, and the point P should be at this point. P should be, this is the origin starting point. Sorry, this is the starting point, and this is the ending point, and the point P should be somewhere like here. Okay, so now you just compare this with this figure and tell whenever the 90 degrees happening, we have B, but we don't have A. Okay, because you can see this A gets omitted. A goes in this direction and B goes in along the axial point, and so we can get that in this case A equals to 0, A equals to 0, and B equals to 1. So from here one can write A means our cos x. So cos pi by 2, cos pi by 2 equals to 0, and sin pi by 2 equals to 1, which is again implies as cos 90 degree equals to 0, sin 90 degree equals to 1. Okay, similarly, if I consider x equals to 180 degree, or you can say only pi, in that case, if I draw the figure, what I will get? This is the starting, this is the unit circle, this is the starting, and this should be the ending. So in this case, if you just look at this thing, so here is our point P, here is the point P. Okay, now What about this A and B? Okay, so let us draw this again. Here, this is our, okay, here, this is our A. This is our A, but B is 0. Here, this is our B, but A is 0. Here, this is our A again, but in negative direction. So A will be here -1 and B is 0. So this thing implies us that cos pi equals to -1, sin pi equals to 0. Okay, and if is equals to 270 degree, that is 3 pi by 2. No. There will be 3 pi by 2. 3 pi by 2. Then what happened? In that case, let us draw the picture again. This is our unit circle. Blue and red will be the starting and ending point. Blue is here and red one is here. In this case, this is our B. A equals to again 0. B equals to -1 because it is in the along the negative y-axis. Okay, so from here one can clearly write that cos 3 pi by 2 equals to 0, sin 3 pi by 2 equals to -1. So from here, and again we will go to the initial point, that is the case when x equals to 0 or x equals to 2 pi. So from here one can observe one thing, that if someone starts from the point P, let us change some new color if it can be easy to understand. Then okay, green should be a good color. So if someone start the point from P, so after 2 pi rotation, it will again come to the point P, right? But in this case, the rotation will not equals to x equals to 0. This should be equals to x equals to 2 pi plus 0, right? Because it has completed one complete revolution, and after that it have completed x radian more. Okay, so by this one can say that after the 2 pi value, the every value of cos x and sin x will repeat. Okay, so just depending on this A and B, so we can find all values of real number, all values of x, that is all real number we can find. Like after 2 pi, it will repeat these values again and again and again. So in each 2 pi value, the one exact point, like if I get cos x equals to some particular value, say p, then cos x plus 2 pi will give the same point p, or same value p. Similarly, it will repeat again and again. Now question is, what about this value of a and b? Now clearly we can see we can vary this value of a and b between -1 to 1. So the value of a and b is between 1 and -1. So from here one can clearly say that this cos x and sin x will be between -1 and 1. So cos x should be less than 1, less than -1, and the value of sin x will be less than equal to 1, greater than equal to -1. Since a less than equals to 1, greater than equals to -1, b less than equals to 1, greater than equals to -1. Okay, so depending on the value of a, we can say that cos x and sin x will not exceed this range. So this thing gives us that this function, if I say sin x and cos x are function, then sin function is a function from the real number set R to the domain -1 to 1, and cost function is a function which assumes the real number set and it will give the values between -1 to 1. Okay, so thus we can find the domain and range of the sine and cos function, and we have given some particular values. Okay, now we have said that after each 2 pi value, the value of this if each function will get repeated. Now one thing you can observe that cos 0 0. Now after you can see, if you add more pi distance, it will again arrive at the point 0, that is equals to sine 2 pi, which is equals to sine 0. So we will again get 0. Again, if we distance pi measure or pi radian, we will again get sine 3 pi, which is nothing but sine 2 pi plus pi. So in each 2 pi rotation, the value gets repeated, so it will equals to sine pi, and it will again give 0. So from here, one can say that sine n pi equals to 0 for some integer n. Okay, and similar way, if one observe carefully, then one can see that cos 2n plus 1 pi, so not pi, it should be pi by 2, this should be 0 for some integer n. Okay, now integer means it can be positive, negative, and all these parts. So in every 2 pi distance, this will give us the value. So in for sine n pi equals to 0 for some integer n, for for all integers n, for some integer, not for some integer, for all integer n, and this will give for all integer n, all integers n. Okay, so we have discussed in this class that the range and domain and range of the function sine and cos, and when the functions have the value 0, okay, for each rotation, and note that for both the functions, sine of x plus 2 pi equals to sine x, and cos of x plus 2 pi equals to cos x. And even we can write this not like 2 pi, we can write it like 2n pi, and we can write this a similar way, that is 2n pi, or n is integer. Okay, so we will end this class here, and in the next class we will go with some more trigonometric functions which we can be modified, or which can be get from using the sine and cos function, that are called like cosec function, cosec, sec, tan, and all those functions we will discuss in the next class.